Okay, so I believe on Friday, we covered this first example, and that's as far as we got. Does that sound correct? The better notes you guys take, the better it is for all of us.
Friday?
Or not Friday, Wednesday. Sorry, on Wednesday we did this. So let's do one more example, and then I'll give you guys your assignment, and we'll try to get your assignment close to finished in class. These problems take a long time, but it's because it's basically covering everything that we've learned this unit. This is probably by far the longest, biggest unit that we have in this class. So we make it through this, and I think it gets at least not as many steps all in one problem. So our goals, the instructions here are find all zeros. By all zeros, that means we're working with like real and imaginary. So real and imaginary zeros. So a couple of our steps would be, if I think about how we've done these before, this one they didn't give us a zero. So sometimes like on this previous example, if we're lucky enough to be given a zero, then we would work with that. If we don't have a zero, how could we find the first few zeros? What are some ideas on how we can figure out what some of the zeros are? Any thoughts? Yeah, Maddie.
Well, I mean, just by looking at the example, we already know there's going to be 3 zeros.
Very good. So we do know that there's going to be 3. Very good. So a reminder to everybody else, we know that there's 3 because of that power of 3. So now we at least know we're looking for 3 zeros. Could we use our calculator? We could use our calculator. If I'm going to use the calculator, I would still make this list of possible rational zeros and then see if it crosses at any of those numbers. So I'm going to make a list, and on your test, you're going to be asked to just make a list, possible rational zeros. This just means nice numbers.
Aren't we allowed to use our notes on this?
Yes, and you can use your notes on your test. Yep, so definitely and any assignments, like this whole spiral notebook, however organized you are, the better you're going to be. Okay, so we always do the factors of the last number, which is why on my notes I'm making them like writing extra, so that when you look back, you'll remember where we got these numbers from, divided by factors of the first number. So the last number is the 5. Don't worry about the negative because we're going to do a plus or minus anyway. And then the first number is a 1. So we need all of the factors of 5 over the factors of 1. What numbers can divide 5? 1 and 5. What numbers can divide 1? 1. So our list would be plus or minus 1 or plus or minus 5. So now when I look at the graph, I'm going to look at the graph and see if it crosses at either positive 1, negative 1, or positive 5, negative 5. My hope is that it at least crosses at one of those numbers. Okay? So if you don't have a calculator, feel free to go ahead and get up and grab one. You can sanitize it as you take it. And we're going to graph this original function. You get a calculator. Our test will be Thursday in class. So you will get a graphing calculator the whole time. So on test, you get a graphing calculator and your notes. So when we do this, you're going to go into your y equals, and we'll enter in this function. I'm going to share my screen. My calculator. Okay, I want this. This. Okay, so again, in my calculator, I'm going to go into y equals, and I'm just entering in this cubic function. Okay, so that I can still see it. So I'm going to go my y equals, turn on. Come on, calculator. On. Nothing is cooperating. Mine isn't showing. Okay, I'm going to try to close it and just reopen it. Okay.
It's Monday's fault.
I know, it's Monday. Okay, yeah, at least it's turned on now. Okay, so in my y equals, if there's other stuff in there, I just clear out. I like to clear out all of them. I don't want to see other extra stuff. My other classes have been adding things. So I'm entering in x raised to the third. I always arrow forward so I'm not still in the exponent. Plus 2x squared plus 2x and then minus 5. Okay. How many times, what's the most number of times that this graph could cross the x-axis?
3.
3, because of degree 3. Okay, it's possible it might only cross once and then have 2 imaginary. So let's look at the graph. My window looks like it's a little off. If your window's off, I'll change mine. I'm going to hit zoom 6, which is probably what you guys have. So zoom and 6 puts it at a 10 by 10 window. I expected the graph to start low and end high. So this is good. It had a little wiggle right here, but it's only crossing at one number. So that means it's going to have one real 0. The other 2 must be imaginary because they're not crossing the x-axis.
Could we have the students with the last names beginning with the letters I through L go to the art building on the second floor for makeup pictures? Again, students with the last names beginning with I through L, or anyone we've missed the earlier alphabet as well, go to the second floor of the art building. Thank you.
Okay, so it's crossing at what number? What number is that graph crossing the x-axis at?
1.
1. So I would kind of make a note on my paper. I'm just going to sketch the graph and say, okay, it's crossing at x equals 1. Well, that is our first 0. We were trying to find 3 zeros, and we now have one of them. Once you have a 0, either by using your calculator or they tell you, then we're going to do synthetic division if it's a real 0. So if it's a real 0, we put the 0 in the box. Okay, so the 0 goes in the box. And then we list the coefficients. When we list the coefficients, we're listing the 1, 2, 2, -5. So we list all of those numbers. So 1, 2, 2, -5.
Wait, so this, sorry. So the 0 will replace the 1. There's no.
The 0 goes in the box. It didn't replace anything, so it's whatever this number is, that number goes in the box. These numbers are just the numbers that were from the front. So like that 1, 2, 2, and -5. You will always have one more number than your degree. So it's a degree 3 polynomial, and I have 4 numbers listed. If it skipped a power, you would have had to include a 0. Okay. Then after we have these, now we draw a line, we leave a little bit of a space, we drop the 1, and we're doing synthetic division. Remember, with synthetic division, you take the number from the box and you multiply the number underneath. 1 times 1 gives us 1, and then we add those 2 numbers. Well, 2 plus 1, we get 3, and we just repeat this process. It's just the same process again and again. So I multiply, it gives us 3. What do I expect the remainder to be?
0.
0. 2 plus 3 is 5. And then we do this process again, the process being the number from the box multiplies the number underneath. We multiply and we get 5. We add and we celebrate, woohoo. Why did I know, or why did I expect the remainder to be 0? Why do you think? Yeah, Giovanni. Take a guess, you're probably going to be right. I bet all of you know, but you're just not vocalizing it. Why did we expect it to be 0? Would it have worked if I put a 2 in the box? No. Why does it work when I put a 1 in the box?
Because 1 is 0.
Exactly. Thank you, Lyndon. Because 1 is a 0. If you're dividing out that x-intercept, that is a 0, so we expect a remainder of 0. Okay, now I'm going to try to write this in factored form. So factored form would be, we take this 0, the 0 of 1, and you write what factor it came from. If you have a 0 at 1, remember it came from a factor of x minus 1. You change the sign when you put it in the parentheses. Then we have these 3 terms. Well, we started with an x cubed, so remember the term we started with. We did synthetic division one time, so now it drops to x squared. So that 1 is going to be followed by an x squared. The 3 will be followed by an x, and then just a plus 5. So all we did was put those numbers to form a quadratic. I knew it would be a degree 2 because you just dropped by 1 power. We went from cubed to squared. How are we feeling? Good? Okay, on the graph, based on the graph that there was only one x-intercept, I knew that there were going to be 2 imaginary zeros. I knew that there would be imaginary zeros because it did not cross 3 times. Imaginary zeros are the ones that come from not crossing the x-axis. That means I'm not surprised that this quadratic I'm not able to factor. I can't factor that quadratic. I know it. I could try. You can watch me try for a second. I could try x into x. The only way I can get 5 though is 5 and 1. There's no way a 5 and a 1 could ever give me a 3. So factoring is not possible. If factoring isn't possible, that's when we go to quadratic formula. Okay, so if we do the quadratic formula, we'd have A is what?
A is
1.
Yeah.
Good. What's B? 3. What's C? 5. Quadratic formula, remember you get to use your notes, so hopefully you have this somewhere that you can always refer to. X equals opposite of B plus or minus the square root B squared minus 4AC all over 2 times A. Okay. Now we just plug in the numbers. So negative B, what will we write, Keaton? Can you tell me what numbers I'm going to write as I plug everything in?
Negative B, that would be 3.
Good, so negative 3, good. Then plus or minus the square root. What's going to go under the square root?
3B to the power 2.
Good, so 3 squared, so we good. And then
4.
good,
And then 1.
Good.
Parentheses around that, right?
perfect,
C parentheses around 5.
perfect. And then I say all over, so the division bar has to go all the way back to the negative 3, all over 2 times A. So notice how I have it written out where anytime I plugged in a number, I put it in parentheses. In fact, I probably should even keep that 3 in parentheses. So any number that I plugged in, if you do parentheses, then you can just type it in on your calculator. So at this point, you enter in the stuff underneath the square root on your calculator, or do it in your head if you like to do math in your head. But you're typing in 3 squared minus 4 times 1 times 5. So when we do this, I hit second quit to go to my main screen, and I'm gonna, hit clear. So I'm gonna enter in just the 3 squared, do not type in the square root. I'm typing it in exactly as we have it written with the parentheses and everything. Now again, if you want to do it in your head, you're welcome to. Sorry, mine's off the screen. Do you guys agree I got negative 11? Anybody else agree? Okay, remember I mess up all the time, so never fully trust me. Okay, so that means that that number under the square root is negative 11. So we have x equals negative 3 plus or minus the square root. I have a negative 11 under there. And it's all over 2 times 1, but 2 times 1 is 2. Am I done?
No.
No, I'm super close, though. It's the only thing I have left to do. Basically, yeah, Giovanni. Good. Everybody okay with that? Was that what you were going to say, Giovanni? Yeah. Okay, great. All I want to see is that that negative comes out in front as an I. So our answer will be negative 3 plus or minus I root 11 all over 2. How many answers, how many zeros is this? 2, because of the plus or minus. So if I were to list my answers, I could say the zeros, which I know that there will be 3. What was the first 0? 1. So I had a 0 at 1. I had a 0 at negative 3 plus I root 11. I'm going to write mine separate. You do not have to. And then I had another 0 at negative 3 minus I root 11 over 2.
Would that matter if we didn't write that?
Nope. I'm perfectly okay. If you wrote it in the lazy way, because most of the time I'm lazy, if you wrote it as 1 and then negative 3 plus or minus I root 11 over 2, those two are saying the exact same thing. I just want to emphasize the fact that we said we were looking for 3 answers, so technically there are 3 answers. Even when we use the lazy version, this counts as 2 answers. Not too bad? Okay, So I'm going to pull up your assignment. I'll show you it's on Canvas, but I'll project it too, so we'll just go through it that way. Yeah,
I think you said for us to do number 1, 4.
okay, sorry, I said to do what?
You said to do 1.
Oh, did we
4.
start it last week? Okay, we did one of them together, that's right, thank you for reminding me. So,
Oh, we did 1 and 4.
yeah, sure.
Okay, we started 4.
We started it, okay, perfect. So I've moved the assignment in Canvas so it's easy to find, so it's under today's date again. So at the top of the modules, you'll see today's date, here's your assignment. And yeah, if you were with us on Wednesday, you probably already started it. Oh yeah, we did 1 and 4. Were you guys okay on 1 and 4?
We started 4.
We started 4. Okay, so let's finish 4. Okay, so if you haven't started your assignment, just on a separate piece of paper, you can label it and work through some of these with us. And I don't care if you do them out of order. I'll start 4 from scratch from the beginning. So all I would want, like on a separate piece of paper, you would just label a piece of paper. Make sure you have your name, so when you submit it. And then the assignment, what was it, 2.12? I always need that written at the top so I know when I'm looking at hundreds of assignments that I know, make sure I'm giving credit to the correct spot. And then you can just start with 4. You still have to do all of the questions, but you don't necessarily have to do them in order. If we're jumping around in class, you can jump around on your paper. Okay, so problem 4 gave us this. It tells us x to the third minus 5x squared minus 5x plus 22, and they're telling us a 0. That's basically helpful because we don't have to graph it on our calculator. How many total zeros do we expect to find? 3. Based on this, I expect there to be 3 zeros. And we have one of them. What do we do with that 2? If they tell us we have a 0 at 2, what do we do? Say that again? Synthetic division, very good, you're right. There are 2 types of division, and synthetic division is the easier one. So we put the 0 in the box. So we put 0 in the box. Natalie, what will the coefficients be as I start this synthetic division? What number should I write here? So it's always these numbers in front. So remember, I'm just going to put the numbers from here. So I'll list 1, then a -5, then a -5, and a 22. Quick reminder, if it's a degree 3, I would want 4 numbers here. If I skipped a number, I'd have to include a 0.
Oh, so we just start right away on this.
Exactly, yep. So it let us skip the graphing part because they told us a 0. Okay, so I'm going to drop this 1. So Natalie, do you remember synthetic division? After I drop the 1, now what do I do? Perfect, multiply it by 2, and we're going to get 2, and then we add. So when we add those, we get a -3, and we just keep repeating this process. Okay, Tyler, what do we expect our remainder to be when we do this? -6, or sorry, -6 is what I have right now. At the end, do you know what we expect this remainder to be? 0, perfect. So let's see if I can keep going. You guys are probably faster than me. So I do synthetic division again, -22, and I'm thrilled because there's a 0 again. That's what we expected. I expected that to be a 0. I expected it to be a 0 because we divided out the 0 that they told us. Yeah, Sean.
So when we do the quadratic, like when we get like the quadratic,
Uh-huh.
how do we know whether to do long division or quadratic formula?
Good question. So once we get the quadratic, your 3 options are factoring, using square roots, or quadratic formula. So let me get to there and I'll tell you, but that's a great question. So the 2 comes from a factor. What factor does the 2 come from? X minus 2. And then these 3 give us the quadratic. How did I know it would be a quadratic? How did I know it would be x squared?
Because they gave us the 0.
We already have a 0.
What was the original degree of the polynomial? 3. So if the original degree was 3 and we did synthetic division 1 time, we know we're down to a quadratic. So then this quadratic would be 1x squared minus 3x minus 11. So Sean's question is, if I'm understanding correctly, once we get to this point, how do we know if we like do quadratic formula? The three options. So our goal now is to solve this equation. So our goal is to solve this, x squared minus 3x minus 11. Our goal is to solve that. What are the three options of solving a quadratic? We have three different things we can do. Factor. Factoring is by far my favorite. It's the fastest. Then there's square roots, where maybe you could just take the square root. And then there's the longest, which is the quadratic formula. So the question being, how do you know which one to do? Unfortunately, there's no easy answer. It's just whichever one works. Okay, so for me, I would attempt factoring because if it factors, that would be the fastest. Yeah, Sean.
What does long division come in?
Long division is when it's imaginary. So long division won't come in on this one at all. So long division, we'll do one of these in a second when they give us an imaginary zero.
Okay.
Yep. Okay, so again, of these three options, factoring for me, I'm fast at factoring, you guys are too. So I would attempt factoring even if I'm just kind of checking in my head. I need two numbers that multiply to 11. What are the only two numbers that multiply to 11? 1 and 11. Is there any way I could get a 3 from that?
Like 3.
Because the outer product would be 11x and the inner product would be 1x. So unfortunately, factoring did not work. So as I'm asking myself, I would go, oh, dang it, factoring doesn't work, which means I'm going to have to do quadratic formula. Square roots, the only time a square root would come up, an example of that, I would only do square roots if it was like x squared minus 4 equals 0, where I only have two terms, because then you could add the 4 over and take the square root. So square roots we do pretty infrequently. So if I can't factor, I then typically do quadratic formula, which is what we did on the last one. So quadratic formula, I'm going to identify A, B, and C. So Jordan, I know you've been gone for a bit, so I just want to make sure you're caught up. A is the number in front of x squared. So what number is in front of x squared? Perfect. B is the number in front of x, so what's B?
-3.
Great. And C?
-1.
Perfect. And then quadratic formula, you can write it down, you can use your notes. So it's this ugly thing. Opposite of B plus or minus the square root of B squared minus 4 AC all over 2 times A. Okay, so now our goal is to just plug those numbers into this formula. Okay, so Ridge, what will I write? Can you tell me what numbers I'm writing as I write this out?
X equals -3.
Good, so it's a negative of a -3, right? Because there's a negative here to begin with, and then it's B. So this is why for me, when I read this as opposite of B. So what is the opposite of a -3? Positive 3, perfect. So I'm actually going to write a positive 3, then plus or minus the square root. Okay, what's going to go under the square root, Rich?
3 squared
Perfect, and let's make sure we keep that -3 in parentheses.
minus 4 first.
1,
And then -11.
good. And it's all over what?
2.
Yeah, times 1, but you're right, it's just 2, so you can just write 2
How come we would change the sign
on the first one,
yeah.
because that's the formula. So that's why when it says negative B, I always read this. When I see negative B, that stands for opposite of B, meaning you always change the sign on that first number in front. Okay, so once we get to here, now what?
So if it's a positive, you change.
Exactly. Yep. Giovanni, what do you think? What do we do now? Okay, which part? In the square root, perfect. So you can choose to do this in your head or on your calculator. If you're doing it in your head, great, but you might want to even check on your calculator. Okay, when we type this in on our calculator, remember we type it in exactly as it looks on our paper. So I'm going to say, hit clear. Do not type in the square root. The -3 has to be in parentheses. If you don't put it in parentheses, you're going to get a different number. So -3 squared minus 4 times 1 with the parentheses, and then the parentheses around the -11. And Sorry, I guess you can't see my screen. Does somebody agree with me? 53? Yes? Okay, thank you. So then I come back. That means that the number underneath the square root is a 53. So we have x equals 3 plus or minus root 53 all over 2. How many answers did we just find?
2.
2. So when I go to make my final answer, list all of the zeros. Zeros, I'm expecting 3. I'm expecting 3 because of that power of 3. What was the first 0? 2. And they told us that, so we know 2. I'll do the lazy version this time. 3 plus or minus root 53 over 2. But that counts as 2 zeros. So I know that I found all of them. Okay. So Sean had a good question about long division. Long division will come up on a question like 2 or 3. We'll have to do long division when the 0 that they tell us is imaginary. Okay, we've only done one of these examples. I would say that this is probably the most difficult. Let's do 3 together. It's a little bit more difficult. Then I think you'll be able to do 2. Actually, no, let's do 2 because it skips a power. So let's do 2. Okay, so on 2, and again, you can just go out of order. So this can be the next problem on your assignment. On number 2, they give us the polynomial x to the 4th minus 3x squared minus 4. So before I even go any further, what do you know about this? How many zeros are we going to have to find? 4, right? This exponent, always the degree of the polynomial tells you how many zeros. So zeros, there will be 4 zeros. We have to find 4 zeros. They told us 1 0 of I, but I actually know a second 0 without doing any work. Remember, because i's come in pairs, like your eyes come in a pair. If you have a 0 at I, where else do you have a 0? Negative I. They come as a plus or minus because it always comes from that square root where we have the plus or minus in front. So right away, I know a negative I. So they told us 1 I. We know the other one right away. Okay. The thing that's different is we will not do synthetic division with I. If you have I, you have to find the quadratic that they came from and then do long division. So if you have a 0 at I, this is different. But I'm going to remind us of how we've done it before. If we had a 0 at 2, the 2 came from a factor of x minus 2, right? So what's our rule? If they tell us a 0, we change the sign to get the factor. So I'm going to do the same rule here. If I have a 0 at I, what factor did that come from? X minus I, right? So I write x minus I. If I have a 0 at negative I, what factor did that come from? X plus I. Everybody okay to hear? Now we multiply these together. So we're going to multiply these 2 binomials together. When we multiply them together, I do x times x times x is x squared. The outer product, x times I, you can write xi or you can write ix, either way, but it's a positive xi, or again, ix, the order does not matter. Then you do the inner product, negative ix or xi, doesn't matter. Negative I times positive I is what? What's I times I? I to what power?
Squared.
Squared, I squared, thank you, Lyndon. Then you have a negative times a positive, so it's a negative I squared. You have something in your notes. You have quite a few things in your notes. I squared, you should have memorized. What is I squared equal to?
-1.
-1. Very good, Giovanni. So maybe tomorrow, one thing we'll do tomorrow is we'll make 1 page in your notebook of the notes that you can like find things easily, so you're not having to go through your whole book.
With those last names begin with M through O, and anyone that has been missed from the beginning of the alphabet, go to the 2nd floor of the art building for makeup pictures.
Okay, so the I squared turns into a -1, but there was the negative in front. So what's the negative of a -1? Positive 1, so that turns into a +1. What do you notice about these 2 terms in the middle? They cancel out. Guess what? Every single time you do this, those are going to cancel each other out. One's positive and one's negative. They will always cancel each other out when you're multiplying an imaginary 0 times its conjugate. So the only thing we have left is that x squared. So we have x squared plus 1. Yeah, Giovanni. A conjugate is just a pair of imaginary numbers. So where one's plus and one's minus. Okay, now just to re-emphasize this, you don't necessarily have to write this on your paper, but I'm going to show you why this matters, like what it is that we just found. We just found the quadratic that gives us zeros of I and negative I. So if I had asked you to find a 0, you would take this and set it equal to 0. In this case, I would use square roots. I could minus the 1 over, and I'd get x squared equals negative 1. What would you do to solve for x? How do we undo a squared? Square root. Anytime we draw a square root, we'd have a plus or minus. But what's the square root of negative 1? What happens when we take a square root of a negative? What do we get?
A positive. No.
Imaginary. So this would be x equals plus or minus I. Well, yeah, that's what we were supposed to get, right? So the goal was, given these i's, can you find the quadratic that it came from? Okay, so you don't have to do the work that I just went through. I just wanted to make you believe that the reason that we did this was our goal was to find the quadratic that gave us those zeros. I know if I took that quadratic and set it equal to 0, I would get those two answers. Okay. Now we have to do long division. So if you start with imaginary zeros, you get to here, and now we do long division. Long division would be we put the x squared. I have to put a 0x and a plus 1. Why do I have to put that 0x there? Yeah, Giovanni. Maybe. Yeah, what's the order? It's a blank form, a certain type of form. Standard form, I think is what you're going for. Yeah. So it's like we don't want to skip a power. If it skipped a power, I always think it's like a placeholder. So x squared, then an x, then a 1. Then we list the coefficients from here. Are we going to need any zeros when we list this? Did it skip any powers?
Yeah.
Yeah, which one did it skip? X to the third. So in between here, there needs to be a 0x cubed. So when I list this, I'll list x to the 4th. I'll list 0x cubed, a minus 3x squared, and a minus 4. Long division is definitely worse than synthetic division. So I would agree. Yes?
How did you get the x to the second 0x plus 1?
So that came from right here. So that's why we did that part. So because once we used the zeros, I and negative I, we took that and we just included the 0 in there.
Was that an O and an X?
A 0.
0.
Yeah, so a 0 because it skipped that one. All right. So long division, our favorite thing, right? Right. It's our least favorite thing. Like every math student in the building, I can promise you, hates long division. So you're not alone. But it's not terrible. So we ask ourselves, what do we have to times x squared by to get x to the 4th?
Squared.
X squared. So I put an x squared on top. Then you take the number that you put on top, let's say I'll do green, and that number has to distribute to every term in front. What's x squared times x squared?
X 4.
Good. X to the 4th, which we expected, we wanted it to match that first term. Then you multiply it by the next one.
X to the 3.
Good.
0.
Exactly. Since there's a 0, 0 times anything is 0, so it's 0x cubed. Yeah, Sean.
At the exponent.
We did. When we multiplied, we did, right? We did 2 plus 2, and that gave us 4. And then we did 1 plus 2, and that gave us 3.
I mean, with the 0. Oh, you add the exponent.
Add the exponents and multiply the coefficients. Yeah. X squared times 1 would give us a plus 1x squared. And then there's something different that we have to do on long division. What do we have to do on long division at this point? I'm ready to combine those. But before I add them together, do you remember? Right now,
Bring down the negative 4.
right now, will these cancel each other out? The x to the 4th and x to the 4th? What do I have to do?
Oh, switch the sign.
Switch the signs. Very good. So at this point, you go down and you switch every sign. So I switch this, I switch this, I switch this. Then you add them together. You have to switch the sign because you wanted the first term to cancel out. If it didn't cancel out, we didn't do it correct. Okay, well, 0 and 0, that's fantastic. That's gone too. We have a negative x cubed, or sorry, a negative 3x squared and a negative 1x squared. So those two give us a negative 4x squared. And then the negative 4 just drops.
So you would have to change the sign on every single one.
Before you add, exactly, yep, all the way down. Okay, if it's made sense to this point, it's an exact repeat. If that didn't make sense, join us right here because I'm going to repeat the same steps. Okay, so if you were a little iffy, it's okay. Our process is the same. We go, okay, whatever number's in front, we want it to be this number. What do we have to multiply x squared by to get a negative x?
Negative 4.
A negative 4. So we put a negative 4 here. Whatever number you put on top, you then have to take that number and distribute it to all the terms in front. Well, negative 4 times x squared is a negative 4x squared. What about negative 4 times 0x? Yeah, Leah.
Don't we need to have the,
You're right. I just am noticing that. Do you guys catch that? Because right now I'm looking and I go, okay, well, negative 4 times 0x, I would get a negative what? 0x, but I've got a 4 and an x and they don't match up. So I did forget to put a 0 here. So let me show you. So she's noticing right here. Do you see how I went from x squared to 4? There wasn't an x term. So I'm going to squeeze in a 0 term. All it really is a placeholder. If you recognize that you could do this without doing it and you just keep everything lined up, you'd be okay. I'm just squeezing in that 0x because it skipped the power. So really I should have had negative 4x squared, 0x, then negative 4. That again just keeps all of those powers lined up. Then I have to times the negative 4 by 1. Negative 4 times 1 gives us a negative 4. And now what? Change the signs. Very good, Leah. So we change the signs. You have to change them all the way down. And we're celebrating because what do we notice? A remainder of 0. We expected a remainder of 0 because the thing we were dividing out was built from zeros. Okay, so whether you're doing long division or synthetic division, if you're doing it based on the 0 that they told us, we expect the remainder to be 0. And now I know you're going like, oh my gosh, are we not done? Because our goal is to find 4 total zeros. Right now, we have 2 zeros. How many more zeros do we have to find? 2. Well, notice they come from this quadratic that's up here. Okay, so I take the quadratic that I have up here. That's x squared minus 4. I know that that should be multiplied by x squared plus 1. If I were to multiply these two together, x squared plus 1, because that was this one here, these two will multiply back to the original. I'm not going to do it. This blue one, I already know that the zeros from here were negative I. I know that this one was negative I and positive I because those ones were told to us. The other 2 zeros that we're going to find are from that red quadratic, x squared minus 4. And don't worry, this one's actually going to be super easy. To find a 0, you set it equal to 0. So x squared minus 4, and I set it equal to 0. And then I solve. What would you do to solve this? This is the time where I would use square roots because I only have 2 terms. What can I move to the other side?
The I, the negative 4.
Good. How would we move that over?
The add 4.
Exactly.
Sorry, I couldn't speak.
No, you're good. You got it. Okay, x squared equals 4. Now what? How do we get rid of a squared?
Divide.
Not divide. Square root. Good. And we expect 2 answers. What do we write in front of a square root anytime we draw it? Did I hear it?
I.
Not I. And I is if it was a negative underneath. Plus or minus. What is the square root of 4? 2. So our answers, we have 2 and negative 2. Those are our zeros. Well, notice that's 1, 2, 3, 4. We found all 4 zeros. Not terrible. Pretty terrible, but okay. Yeah.
So with the first parentheses, x squared plus 1, Why is there a square in there?
Because we got the x squared plus one by multiplying x minus I and x plus I. Those two, when we multiplied together, we got x squared plus one.
Why don't you have to take out the x squared though?
No, this first factor will be the factor that came from the imaginary zeros. And then your second factor will be what you got after you did long division.
I'm guessing the x squared is imaginary, so it doesn't apply.
If you notice, anytime it's x squared and then plus a number, that's when you're gonna end up with an imaginary. If it's x squared minus a number, then you'll get real numbers. So there are some patterns you can recognize there. But the 2 just means there's gonna be 2 answers. So this gave us 2 answers and those 2 answers were negative and multiplied. This gave us 2 answers and they were 2 and negative 2. Okay, let's do one more of these. This is our last one where I'm gonna make you do long division. Okay, so this is the last one. Then on the back, what you guys have, there's only 2 that you guys will do at home, and these are easier because you have the draft. You will not have to do long division on the back. Okay, so 5 and 6, just so you know, will be like 1 and 4. Okay, so let's just do one last hard one together, and then we're done. Okay, how many total zeros are we trying to find with this question? 4. We're trying to find 4 because of that. They told us 1, but they actually told us 2. We know a second one. If we have 3i, what other one do we also have? Negative 3i. You just change the sign in front, right? So you always have a plus and a minus of the number. So positive 3i, negative 3i.
This one's gonna go on for a decade.
It will be like the last one. Yep. Okay. If we have 3i, what factor did that come from? X plus or minus a number? Minus. We always change the sign, so it would be x minus 3i. Okay, the factor of negative 3i came from what factor? Good, x plus 3i. Now what do?
We times it.
We times them together, good. If we come up here, remember in green, after we wrote them out, we multiplied them together. Every time we do this, we're going to expect that there will be an I squared that will change to a negative 1, and the 2 in the middle will cancel each other out. So let's see if that happens again. So when we FOIL these together, and if you prefer box method, you could do the box method to multiply. X times x gives us x squared. That outer product, I get a plus 3xi, or again, you can write ix, the order doesn't matter. Then you have the 2 in the middle, which is the exact same thing, but a negative. What's the last product? What's negative 3i times a positive 3i?
Negative 9 squared.
Close, negative 9, and then something is squared.
Oh, I squared.
I squared, perfect. Everybody okay here? Okay, now what? Perfect. And that will always happen, right? When you're multiplying these imaginary numbers, the 2 in the middle will always cancel. Something else always happens. What about that last term, I squared? What is I squared equal to? Good. I squared is negative 1, so we make that substitution. What's a negative 9 times a negative 1? A positive 9. So we really have a plus 9. The terms in the middle cancel each other out, so all we have is the x squared. Do you remember the little shortcut I told you from here? Anytime it's x squared plus a number, like when it was x squared plus 1, we got 2 imaginary numbers. X squared plus a number, you're going to get 2 imaginary numbers. Let me show you this again. Again, you don't have to write this out, but that's because if we were to set this equal to 0, we would subtract 9 minus the 9 over, and take the square root. What happens when I take the square root of negative 9? I get a plus or minus. What about what's the square root of 9? We get an I, yep. This would be like I root 9, but what is the square root of 9? 3. So notice these zeros are the zeros we were supposed to get. Okay, so our goal was to create a quadratic that had those zeros, which we did. Okay, So again, I showed you that, you don't have to do that. I'm just illustrating that we found a quadratic that had those zeros. Now we're ready for long division. So we do this, we write x squared plus 0x plus 9 because it skipped the 0. Let me be more careful this time. Did this part need any extra zeros? No, because it went 4, 3, 2, 1 constant. So when we write this out, you guys are lucky on a separate piece of paper. You don't have to like conserve space. I'm trying to make everything fit. Okay, so I have x to the 4th plus 2x cubed plus x squared plus 18x minus 72.
Then you have to have 4x, or 4 right on top.
Not yet. Not that. You ask yourself, what do you have to multiply x squared by to get x to the 4th? X squared. Then x squared goes on top. And then you take the number that's on top and you multiply it by everything in front. X squared times x squared is what? X to the 4th. We do that again. Well, anything times 0 is 0. So it's a 0x cubed. And then a plus 9x squared. And now what? Switch the signs. Very good, Leah. So I have to change all of these signs. And then we add them together. The first pair should cancel out where you did something wrong. My next one, I've got 2x cubed minus 0. So that just stays 2x cubed. Here, there's a 1 in front. So I have 1x squared minus 9x squared. So I get a negative 8x squared. And then we just drop the other stuff. Now repeat. When we repeat the process, we always say, okay, this first term, we're trying to get to be this first term. What do we have to multiply x squared by to get 2x cubed? 2x. So I put a plus 2x up here, and then we distribute again. This 2x multiplies. So that gives us a 2x cubed. 2x times 0x. That's a 0x squared. 2x times 9. We get an 18x. Now what? Switch the signs. So hopefully this process is starting to be like, oh yeah, you see the repetition of it. The first pair cancels out. A negative 8x squared and a minus 0, that gives me a negative 8x squared still. It didn't change. Oh, this is great. What do you notice on this next pair? They cancel out. I'm still going to write a 0 just as a placeholder. And then a minus 72. Okay. So what two numbers will I be comparing now? What number am I trying to get? What do I have to multiply x squared by to get negative 8x squared? What do you think? Negative 8. Perfect. So we put a negative 8 up here, and I liked how Struna pointed this out last week. We knew that this would be a constant because we expected it to go squared, like x, and then just the number. So I feel good about that. You take that number up top, you multiply it by the numbers in front. What are we hoping or expecting our remainder to be? 0. So there's the negative 8x squared. The negative 8 times 0. Well, that's a 0x. Negative 8 times 9. Somebody want to double check for me? What's that? 72, and it's a negative 72. Just like we've done on the other steps, we now change the signs. Woo-hoo! You know, if you did this on your own, and I have done these for years, and I still celebrate when I get a 0, because that means we did the problem right. I've screwed these up enough times that it is frustrating if you don't get a 0. When you do, we're happy. Okay, so now we have to remember, okay, well, now that we're here, what do we do? What we want to focus on is this quadratic up here. That's what we care about. That quadratic is going to give us our other two zeros. So let me just emphasize. I'm taking the x squared plus 9. That was this thing up front. That was this one here. I know that if we multiply that by the x squared plus 2x minus 8, and that was this here, that would give us the original function. Okay, we already know 2 zeros from here. What were the 2 zeros from x squared plus 9? These were the 2 that were given.
Right.
Great. How many zeros do we expect to get from here? 2. We have 3 methods. Okay, it's a quadratic. I'm going to remind you, I think I have this still written over here. Our 3 methods. Can we factor, use square roots, or quadratic formula? Good. I'm excited because that looks like it's factorable. X squared plus 2x minus 8. If you can factor, way faster than quadratic formula. So let's see if we can factor it. When we factor, we ask ourselves, okay, what times what could multiply to x squared? You're one step ahead. So first, what
Square,
times what?
square, X squared, X squared,
Not x squared and x squared. X and x.
X and X.
Right. And then now we go to the 8 and we say, okay, what times what could multiply to give us 8? A 2 and a 4, and you could put it in either order, it doesn't matter. Remember, I do signs at the end, so now I check. When I check, thank you. When I check the outer product. What is that outer product right now?
4X,
4x, perfect. What is the inner product?
2X.
2x. What number am I trying to get? 2x. I'm trying to get this middle number. This is why I wait to do my signs till the end. What should I do with my signs so that I end up in a 2x? A negative 2. If we had a positive 4, 4 minus 2, yeah, that does leave us with a positive 2x. So I put a plus sign with the 4 and a negative with the 2. Drum roll. I know. Ah, no,
There you
I
go.
gotta show you the excitement. What are our 2 zeros? This gives us what? X equals what? Yay. Okay, you guys will have to look on Canvas. Okay, the 2 problems on the back are just these 2. You'll need to look at it though, because you'll want to see the graph. Those 2, I promise, will take you a fraction of the time that ours did tonight. So I'd say you should be able to finish that in like 15 minutes. Okay, so I'm not giving you that much homework. It's just those 2 questions. You will use synthetic division. So it'll be similar to problems 1 and 4. Yeah. Yes, perfect. Do you want to just leave them with me, then I'll.
Yeah, so I don't know if I can use this one or this one.
Okay.
I can't remember. And then I think have this one down.
Yeah.
I don't know.
They look good. I'll take them and then I'll give it back to you tomorrow. Thank you. So we can
My
send
grade in
this
this
to you.
class is a D.